Figure 1 shows part of the curve with the equation y equals e to the 1/5 x squared. We are given some values for x and y in the table there, and we need to use the trapezium rule with all of the values of y to find an estimate for the area. So the trapezium rule is half times h times the first y value plus the last y value plus 2 lots of everything in between. So in this case, the h is 0.5. The width of each interval here is 0.5. So replacing the h with 0.5. The first y value is 1. The last y value is e to the 0.8. And then we've got 2 lots of everything in between, which is all of these. So e to the 0.05 plus e to the 0.2 plus e to the 0.45. Substituting that into a calculator and being super careful with those brackets, we get to 2 decimal places, 2.73. And that's your answer for part A. Part B says to use our answer for part A to deduce an estimate for the integral of 4 plus e to the 1/5 x squared. So comparing this to the graph that we have in part A, we've just got the plus 4 difference. So now I'm thinking, well, what effect would that have on the graph? Well, it would just shift the graph up 4 squares in the y direction. So this whole area here would also shift up to be here. And then I would have this extra rectangle underneath, where the area of that rectangle is, well, the base is 2, the height is 4, so the area of that rectangle is 8. So my answer would be 8 plus the area that got shifted up, which is 2.73, which is 10.73. Then for part II, we've got the integral from 1 to 3 of e to the 1/5 x minus 1 squared. Again, comparing this to the graph. Now that x minus 1 on the inside there affects the x coordinates, and I would add 1 to all of the x coordinates. So that's going to shift this graph 1 square to the right. Now, because the limits have also been shifted over, so we're now integrating between 1 and 3, the answer is going to be exactly the same as what it was in part A, because I'm just shifting this whole graph over 1 square. The area is going to be exactly the same. The graph, the limits, everything just shifts over 1 square. So the area of R would be exactly the same, 2.73.